So we'll be starting with illustration 24. As you see, it's a typical sum, so it's very important for exam. So let's read the question. This is on page number 156. Page number 156. Now let's read the question. The information of a number of accidents in 10 days of a particular road is given below. Find the mean and standard deviation of number of accidents per day. Find the percentage. Now this is important. Find the percentage of days having number of accidents lying between the limits x bar plus or minus s. So what is this? I'll write once again over here. X bar plus minus s, standard deviation. So over here we have to find out mean, we have to find out standard deviation, and then we also have to find out percentage of days. So we'll see this later what exactly it is. As of now, let's start solving the question. So number of accidents xi one, two, three, 4, 5. Number of days fi 2, 3, 3, 1, 1. Total will be equal to 10. So n is equal to 10. Now we directly go with the shortcut method over here. Okay. So d is equal to x minus assume mean. We take as 3. 3 as our assume mean. Minus 3. So 0, minus 1, minus 2, 1 and 2. And then f into d and f I di square. So let's do it. F into d, minus 4, minus 3, 0, 1 and 2. So 3 cancel, minus 4. And fi di square is fi di into di. Okay, di, fi di. Okay, so 8, 3, 0, 1, 4 total. 8 and 3, 11, 12, 16. Now we have to find out mean and we have to find out standard deviation. So mean x bar is equal to, because we are using shortcut method, a plus sigma fi di upon n. So mean is equal to 3. Now plus minus 4 upon 10. So which is equal to, why I am using this formula is because there is one concept connected with this formula which we are going to see further. So I am using this formula in this method for this typical sum. Okay, so 3 plus or minus minus 0.4. So mean is equal to 2.6. So mean is equal to 2.6. Now standard deviation. Standard deviation S is equal to sigma Fi di square upon n minus sigma Fi di upon n the whole square and the whole under root, which is equal to Fi di square is 16 upon 10 minus, now minus 4 upon 10 the whole square, the whole under root, which is equal to, so now 1.6 minus, so 4 divided by 10 directly you can do because it's square, which is 0.4 into is equal to the 0.16, 0.16 the whole under root. So 1.44. Therefore, standard deviation is equal to, find the under root, 1.2. So this is your standard deviation. Till now, every concept is clear. Are you all able to do this? Anyone has any doubt? Okay. Now, please pay attention. Now, this is a very important part over here. What we have to find? We have to find the percentage of days having the number of accidents lying between the limits. Limit is what? X bar plus minus S. So first let's find it out. Let's find out. So X bar plus S is equal to 2.6 plus 1.2, which is equal to 3.8, and X bar minus S, minus standard deviation, is 2.6 minus 1.2 is equal to 1.4. So it is 3.8 accidents and it is 1.4 accidents. Now what we have to find? We have to find first percentage. We have to find percentage of days having the number of accidents lying between limit X bar plus minus S. So first we will find how many days, number of days with accident between 1.4 to 3.8. So you see the sum. So this Xi is basically number of accidents. So we have to find out number of accidents between. So therefore, number of accidents between X bar plus minus S, that is 1.4 to 3.8 are. Now we'll take Xi over here कि 1.4 से ज़्यादा, so it will be 2 accident, and 3.8 से कम, that will be 3 accidents. And कितना frequency है उसका? So it is 3 and 3, that is 6. So Fi 3 and 3, so total is 6. Make a small table like this so that you know that accidents between 1.4, so more than 1.4 and less than 3.8. How many accidents are there more than 1.4 and less than 3.8? So that is 2 accident, 3 days, and 3 accident, 3 days. Therefore, number of days is equal to 6, but this is not the answer. We have to find the percentage of days. So therefore, percentage of days having number of accidents between x bar plus minus s, that is 1.4 to 3.8 is. So now there are 6 days out of what? Out of total 10 days. So it is 2, 3, so 3 plus 3, 6. So which is equal to 6 days upon 10 days because percentage, so into 100. 0, 0 cancel, 60%. And there is a very typical sum like this in the exercise which I have solved in my other video lecture which is already there in the app. So when you do the homework, have a look at that as well. It's a typical sum like this. If you have any doubts, mark this sum, illustration 25, extremely important for your exam. Page number 157. Very likely to come in your exam. Now let's read the question. The mean number of units produced by 100 workers of a factory per day. So 100 workers of a factory, so n is equal to 100 per day is 60. So mean is given, mean is 60 and its standard deviation is 10. So S is equal to 10 units. Later on, it was noticed that two workers have actually produced 30 and 20 units respectively, but it was registered as a 5 and 45. So units were 30 and 20 respectively, but they were registered as 5 and 45 wrongly respectively. By considering this, find corrected mean and corrected standard deviation of number of units produced by the workers. So here there are wrong observation. We have to replace them with the correct observation. We have to find the new mean and the new standard deviation. So corrected mean and corrected standard deviation. So let's start with the sum. Now first let's write what is given. So n is equal to 100, mean is equal to 60 and standard deviation is equal to 10. Now we have wrong observation, so I write in red. So wrong observation are 5 and 45. Correct observation are 30 and 20. So let's understand first this concept, exactly what has happened wrong. So I'll draw a line over here. See, you had xi. From xi, you found out x square to find out the standard deviation. So in xi, you had written by mistake 5 and 45. These are wrong observation. So because of this, these wrong observation also you took the square of this, which is also wrong. Instead of this, we are supposed to take 30 and 20. So 30 square and 20 square is what we should have taken. But we have taken this. So first Uh, because of this, what has happened? Our sigma x has gone wrong and our sigma x square has gone wrong. So we'll have to find out first wrong, total of wrong observation and total of square of wrong observation, and then we will remove the wrong, add the correct and find the correct mean and correct standard deviation. So please write this in rough. Okay. Now when we go over here, when we start the sum, now first let's find out wrong sigma x. So this is the first thing what we'll be finding out. So for that, mean is equal to sigma x upon n. You all know this mean is with the wrong observation, the standard deviation is with the wrong observation. So therefore, sigma x is equal to x bar will be multiplied with n. So x bar into n. Therefore, wrong sigma x is equal to x bar is 60 into n is 100, which is equal to 6000. So wrong sigma x is equal to 6000. Let's find the correct sigma x also with this. Or let's do a different thing. First, let's find out wrong sigma x square. And then we do both parallelly correct so that you exactly can correlate it with this working. Okay. So let's go to the next point. Wrong sigma x square. Now there was one formula when we did the raw data formula, and that was S is equal to sigma x square upon n minus x bar square, the whole under root. So we'll be using this formula now. So therefore, standard deviation is 10 is equal to sigma x square is what we have to find out. N is 100 minus x bar is 60, square of 60, whole under root. Now in order to remove under root, I will do square over here. So 10 square, which comes to 100, which is equal to sigma x square by 100 minus 60 square is 3600. Now what is to be done? Now what happens? This 3600 negative will come on the left hand side. So that will become 3600 will become plus. So 100 plus 3600 is equal to sigma x square upon 100. Therefore, 3700 is equal to sigma x square upon 100. Therefore, wrong sigma x square is equal to 3700 into 100. So 3,70,000. So this is our wrong one. So let me mark it in red. So you know these are the wrong ones. Wrong sigma x and wrong sigma x square. This is both what we found out. Now we have to find the correct one. Okay. So now for finding correct, so correct sigma x square, sigma x first, which is equal to wrong sigma x minus wrong observation plus correct observation, which is equal to wrong sigma x is 6000 minus wrong observation, that is 5 and 45, and correct observations are 30 and 20, which is equal to minus 50, same, 6,000. So there is no change over here because minus 5 and minus 45 is minus 50, and plus 30 plus 20 is also 50. So correct sigma x is equal to 6,000. This is what we found out. Therefore, correct mean is equal to 6,000 upon 100, which is equal to 60 units. So this is done as far as sigma x. So we have rectified the sigma x, and coincidentally it remains the same, the wrong and the correct, because we have taken 5 and 45, which is 50. It is also replaced by 50. So minus 50 plus 50, it remains same. So new mean is also 60. Therefore, new mean or corrected mean, let's use the word corrected, is equal to 60 units. Now, let's go for sigma x squared. This is important. Please pay attention over here. Sigma x squared is equal to wrong. So I write over here correct sigma x squared is equal to wrong sigma x squared minus square of wrong observation plus square of correct observation. It means we have to take square of, remove the square of wrong observation, and we have to add a square of a correct observation. These are to be added and these are to be subtracted. So let's go over here, which is equal to 3,70,000 minus wrong observation is 5. You can see over here 5 square minus 45 square plus 30 square plus 20 square, which is equal to 3,70,000. Take a calculator. Minus 25 minus 45 square, which is 2025, plus 900 plus 400, which is equal to 3,70,000 minus 25 minus 2025 plus 900 plus 400, which comes to 369250. So 369250. This is your correct sigma x square. So correct standard deviation is equal to sigma x square upon n minus x bar square, correct mean square, which we have already found out over here, which is equal to 369250 upon 100 minus 60 square whole under root, which is equal to 92.5 minus 3600, which is equal to under root of which is equal to under root of 92.5, which is equal to 9.61769. So 9.62. Therefore, correct standard deviation is equal to 9.62 units. Answer. This is how we have to do this sum. Just go through the sum once again. See if you have any doubts, anything, any step you did not understand, let me know. Now we are going to see some useful results. Now what are these results? Now let's say for example, okay, there are two constant B, constant A and constant B. Okay, there are two constant. Now if A is added to all observation and if B is multiplied with all observation and we have mean x. Okay, so we have values xi. Then what we are doing, we are multiplying all the observation of xi with v. We are also adding a to it. So if a is added to all the observation and b is multiplied with all the observation, what happens? So what we say is, because you can see the observations will change, we will say that new mean will come, mean y or variable y will be equal to b into xi plus a. We get new set of observations. So if this is xi, what we do is we multiply it with b. So it will be b of xi. We get some new over here and then we add a to all the observations. So what we get is set of y, which is what bxi plus a. So we get new set of observations. So we will obviously be getting new mean and new measures. Now, if it was mean, okay, if it is mean x, so mean y, mean of y will be equal to, or y bar will be equal to b x bar plus a. Now, why we do this? Because the measure mean or any measure of central tendency, if something is multiplied or something is added, then what we have to do is we have to calculate that, we have to take that in the formula. And that's why if you are able to recall, because if you will not take it to the formula, then it will not reverse the effect, then what will happen is, then the mean what you will get will not be correct. So we have to see it this way. When we did this over here, okay, I used a formula x bar is equal to a plus sigma fi di upon n. It means what? Over here, I subtracted this observation 3. So 3 was subtracted. Okay, we got b, a new set, then fidi and then fidi square. So what I subtracted over here, I added. And when we go for d is equal to xi minus a upon c. What we do in the formula? We write the formula a plus sigma fi di upon n into c. Now what we are doing? This we subtracted a, so here we added a. We divided c, so here we multiplied c. If we will not do that, then the mean what we will get will not be correct, because we have changed the observation by subtracting something and dividing it by some number. So we say that measures of central tendency is dependent. You may please write this. Measures of central tendency are dependent on change of origin. Change of origin means what? Plus or minus, and are also and are also dependent on change of scale. Change of scale means what? Change of scale means जितने भी ऑब्जर्वेशन है उसको either we multiply or we divide. So change of origin is plus and minus, and change of scale is multiply and divide. So if you convert the original observation by multiplying, dividing, adding, subtracting, similarly the formula will change. What you have added will be subtracted, what you have subtracted will be added, what you have divided will be multiplied, what you have multiplied will be divided, because these measures of central tendency का कैरेक्टरिस्टिक्स ही यही है. दीज आर द कैरेक्टरिस्टिक्स कि उसको फर्क पड़ता है. सो इन ऑर्डर टू एडजस्ट दैट यू हैव टू एडजस्ट द फॉर्मूला. बट इफ यू गो फॉर मेजर्स ऑफ डिस्पर्जन, नाउ व्हाट हैपेंस टू मेजर्स ऑफ डिस्पर्जन? ध्यान दो. फॉर मेजर्स ऑफ डिस्पर्जन they are basically independent. Independent means, I'll come to it, independent of change of origin, it means if we add or subtract from the original series any number, okay, or a constant, there it will not affect the measure of dispersion. So this will be independent. इसको कोई फर्क नहीं पड़ेगा. That will remain the answer what you get will be with the normal formula. You will get the correct answer. But what happens? But the second very important point, it is independent of change of origin, but it is dependent on change of scale. Change of scale का मतलब क्या है? Multiply or divide. And that is why when you go for the formula of standard deviation, okay, fi di square, okay, upon n minus sigma fi di upon n, if you go for continuous, where you have divided, where you have taken d is equal to x minus a upon c, you will see कि यहाँ पे भी you multiply it with c. क्यों? Because why you are not adding a anywhere in this formula? Why we are not adding a? Because d is what? X minus a. Because this formula is unaffected by change of origin. So if you plus minus, उसको कोई फर्क नहीं पड़ता. And that's why in the formula we are not adding a. But if we are dividing it by c, here also you will have to multiply. Because उसको division multiplication से फर्क पड़ता है. तो इसको हम कहते हैं चेंज ऑफ ओरिजिन एंड चेंज ऑफ scale. So this is very important. Please write this. Here it is dependent. And that is why what happens, come to this screenshot of the textbook. So now you come to this, some useful results, and here what you can see is that for range, okay, for x and for y. So if anything is added, उसको कोई फर्क नहीं पड़ता है. But if anything is multiplied or divided, so for change of scale, that is multiplication or division. Now over here in this result we are multiplying. Okay, in that case what happens is you have to use this. The new range will be what? Modulus of b, or a constant with which we are multiplying, okay, into range. For quartile deviation, again b into range. So here you can see that over here SU mean comes nowhere. Nowhere you will find A. But in measures of central tendency, everywhere SU mean was added back when it was subtracted in the original data. And this is how we have to find the new range in case the original data is changed, is added, something is subtracted, something is multiplied, something is divided, then you have to use this type of method where you have to ignore what is added or subtracted and you have to take only what is divided or multiplied to find the new range, new QD, new mean deviation, new standard deviation, or new variance. So please write this. This is important. Okay, now let's see the sum so that you can understand the concept better. Now illustration 28, which is on page number 162, the range, quartile deviation, mean deviation and standard deviation for a variable x are 10, 2, 3, 5 respectively. If y and what? You have xi, then you found out yi, some new set of observation. How? Okay, by multiplying all the observation of x with 5 and then adding 3. So y is equal to 5x plus 3. Find the range, quartile deviation, mean deviation, standard deviation for variable y. Now I'll write once again over here, y is equal to 5x plus 3. Now we have to just see 5x. We don't have to see this plus 3 because dispersion को change of origin से कोई फर्क पड़ता नहीं है. So we just have to multiply everything with 5 to get the answer. So what we do over here, we will say range. First we go to range. Range of x is equal to, what is the range given? 10. Therefore, range of y is equal to 10 into 5, this 5, which is equal to 50. Then quartile deviation QD is equal to 2. Therefore, quartile deviation of x, okay? So, quartile deviation of y is equal to quartile deviation of x, that is 2 into 5, which is equal to 10. Then mean deviation. Mean deviation of x is equal to 3. Therefore, mean deviation of y is equal to mean deviation of x into 5, which is equal to 50. And then standard deviation. The standard deviation of x is equal to 5. Therefore, standard deviation of y is equal to standard deviation of x into 5, which is equal to 25. So you can see for all the new measures, we have ignored 3, but we have taken into consideration 5. So please write this. It can come as a short sum. Now why we are doing this? Because measures of dispersion कोई फर्क नहीं पड़ता. It is independent of change of origin. So if anything is added or subtracted, just ignore it to find the new range, new QD, new mean deviation, new standard deviation, new variance. So for all measures of dispersion, you have to take into account only change of scale, but ignore change of origin. Understood this now? Okay, illustration 29. Now the demand function of a commodity D is equal to 15 minus 2 into P, where P is equal to price in rupees per unit and D is equal to demand units. From the closing price of each month of last year, it is known that for the price, range is equal to 5, mean deviation is 2, and variance is 9. Variance is standard deviation का square. Find range, mean deviation, and variance of the demand from it. Now over here first, let me write this. D is equal to 15 minus 2P. Now range is equal to 5. Mean deviation is equal to 2. Variance is equal to 9. Now over here 15 minus 2p. So this 15 we have to just ignore. We have to ignore 15. We have to not take into account because it was plus, so we ignore. Now it is minus 2 into p, so we have to take that, and over here, as you see over here, it is given modulus, so you have to ignore the negative sign. So over here we write range. So new measures, new range is equal to 5 into modulus of 2, which is equal to 10 units. Then mean deviation is equal to 2 into modulus 2, which is equal to 4 units. But what about variance? See the table over here. Variance will be what? We have to square of that, and square of variance is already given, so we have to square of this constant 2, which is used for multiply. So variance is equal to 9 into modulus 2 ka square, which is equal to 9 into 4, which is equal to 36 units. Which is equal to 36 units.